All right, today we're going to solve inequalities using addition and subtraction. So it's more along the lines of our lessons of solving linear inequalities. When we solve these problems, we're also going to need to add in a graph. So here are directions that we're going to solve the inequality, and then we're also going to graph our solution. When we graph this, what we first need to do is, again, isolate our variable x, get that by itself, and then take the result, make sure that we have the arrow on the appropriate side, and then, and by the arrow I mean the inequality sign on the with the variable on the appropriate side. That way we can utilize that to help us point our graph in the right direction. So first, to start, we're going to add 5 to both sides, right, as we get x by itself. X, when we take -3 and we add 5, of course it's going to be 2. So now that we have this as our solution, we need to graph. Now remember, all that's required on my graphs are that we know where we can place 0 relative to the other number. So I only need 2 tick marks here, 0 and 2, right? 0 going on the left, 2 going on the right. Now, if we look here, our variable x is on the left, which is perfect. It means that we can use this sign right here, this inequality sign, as guidance for which direction it's going to point. So our graph should be pointed to the left. It's an open dot on 2 because it's not equal to, and we're going to shade in on the line, right? Darken that line, including the arrow pointing to the left, given, again, that inequality is pointed to the left. All right. Example number 2, we're going to solve each inequality. So we're going to have we have s plus 18, where it's going to be greater than or equal to 21. Okay? So let's solve this. Step 1 is that we're going to subtract 18 from both sides, giving us s by itself on the left, and we have 21 minus 18, which is 3. So we have s is greater than or equal to 3. The variable is on the right, is on the left, so we only need the numbers relative to where 0 is. So 0 and 3. 3 is positive. It's to the right of 0 on the number line. I have a closed dot this time, correct? Because I have, for my inequality sign, I have greater than or equal to. Because of equal to, it's going to be a solid dot. And then it's pointed to the right, so we will shade to the right. And we can follow that direction because our variable is on the left side. Let me read this. Next. I have negative 5.2 greater than x plus 2. Again, I need to get x by itself. So what do I need to undo? Well, I need to subtract 2 from both sides. Okay? So what do I have? Well, negative 5.2 minus 2 is negative 7.2. Still greater than x. Our answer is done there. But the other way we want to write this, guys, is we want to write this where x is on the left side. So remember, we have to flip our inequality sign for, as we discussed previously. We want to flip our inequality sign to make this an identical statement, right? Because remember, let's take for example, that we had 0 here, right? Or moreover, we need something where it's greater. Well, let's say we had negative 10 right here, right? So if negative 7.2 greater than negative 10, which is true, right? I would have to flip the sign, right, to demonstrate that the negative 10 is still less than negative 7.2 as soon as I flip which side that thing's on. So that's why we have to do that. Now, why it also helps to rewrite it that way is we can utilize this trick only when the variable's on the left, where we can just look which direction right? Because we're looking that this guy points to the left for the inequality sign for less than. Therefore, we're also going to point when we shade to the left. So we have where we are relative to 0. Well, negative 7.2 is less than 0, so it goes first. It's to the left of 0. It's an open dot because it's not equal to. And again, we shade to the left because the inequality sign has its point on the left. And remember to include the arrow, otherwise it is not correct. So there we go. That's what it should look like right there for you. Okay. And our last example for today. Quick instruction. We have an electric grill. That uses 1,600 watts of electricity. And it's plugged into the circuit described in example 3. We're going to write and solve an inequality. Described in example 3. I'm reading something directly from the textbook. So let's erase that into the circuit that overloads a 1,800 watts of electricity. Write and solve an inequality represents how many watts you can add to the circuit without overloading it. I'm sorry. So, how do we set this up? Well, what it means is that there's going to be a total wattage that we have to stay under, right? So we have to stay less than the 1,800 watts. If we exceed that, it will overload the circuit and it will actually burn it out. Or you can burn out your appliance. Just depends on how your wiring's set up, right? Then if you have something that will break that circuit. So we have 1,600, which is less, right? And how many more can we add? Well, we're going to add some number of watts, okay, to that same circuit. And at that point, we've overloaded the circuit, okay? So you can go up to 1,800 total. So this is how we'd set it up. We have our 1,600, right, of our electric grill, and then over here, the 1,800 represents the total that we can have till we have overloaded it. So that's how we'd interpret this, right? That we have to stay under something, and it has to be less than 1,800. So this is pretty straightforward to solve from here, right? Once we have this set up, then we're going to have W, of course, is going to be less than, and 1,800 minus 1,600 is going to be 200. So what does that mean? It means that you can add up to 200 watts before you've overloaded your circuit. It can cause a malfunction. That is all we have for today. Your homework assignment is posted on Canvas. Good luck.